Why does a data scientist need to care about evaluation metrics in classification models? Well, imagine creating a model to predict whether an email is spam or not. The model seems to work fine most of the time, but occasionally it flags important emails as spam. This error could lead to missing out on crucial information. To avoid such scenarios, the evaluation of classification models becomes crucial. Evaluation metrics provide a way to measure the performance of a model. They serve as a guide, offering a glimpse into how well the model is doing and where it might need improvement. But not all metrics are created equal. Some are better suited for certain tasks than others. Consider accuracy, for example. It's perhaps the most intuitive metric. It measures the proportion of total predictions that are correct. Simple to understand, right? But accuracy can be misleading when dealing with imbalanced data sets. Imagine a dataset with 99% non-spam emails and 1% spam emails. A model that predicts every email as non-spam would have an accuracy of 99%, despite failing to identify any spam emails. That's where precision and recall come into play. Precision measures the proportion of positive identifications that were actually correct. In other words, out of all the emails flagged as spam, how many truly were spam? Recall, on the other hand, measures the proportion of actual positives that were correctly identified. It answers the question, out of all the actual spam emails, how many did the model correctly flag? While precision and recall are powerful, they have a trade-off. Improving precision may reduce recall and vice versa. This is where the F1 score becomes useful. It's the harmonic mean of precision and recall, providing a balance between the two. However, the F1 score might not always be the best choice. For instance, in a medical diagnosis model, missing a positive case could be fatal, making recall a more important metric. On the other hand, in a spam detection model, precision might be of greater concern to avoid flagging important emails as spam. Moreover, there's the ROC-AUC, or receiver operating characteristic, area under the curve. It's a performance measurement for classification problems at various threshold settings. ROC is a probability curve, and AUC represents the degree or measure of separability. It tells how much a model is capable of distinguishing between classes. In conclusion, the choice of the right evaluation metric depends on the problem at hand. Accuracy might be a good starting point, but it's not always the best metric, especially for imbalanced datasets. Precision and recall provide more insight into the model's performance, but they have a trade-off. The F1 score provides a balance between precision and recall, but the importance of each depends on the specific situation. Finally, ROC-AUC provides a measure of a model's ability to distinguish between classes. Remember, the goal is not to maximize the metric, but to understand what the metric is saying about the model and use that understanding to improve the model. So consider the context, understand the trade-offs, and choose the metric that best fits the problem at hand. After all, the model is only as good as its ability to make accurate and useful predictions.